Hey everyone, another extracurricular circuit I made was a real labor of love. It's Bluetooth connection from an Arduino to a Raspberry Pi. So this is something I'd started even before the course, but I had limited experience with an Arduino and even less experience with a Raspberry Pi and know basically nothing about Linux, so I've been learning as I go. So this took an extremely long time to get working. You're looking in the range of probably 30 hours, maybe even longer than that of troubleshooting and forum reading and all that. A big part of it was I originally started out using this Bluetooth module, which is a ZS040. So this is low energy Bluetooth. I got it off of Amazon for fairly cheap. There's a few reasons why I bought this one originally. Is because it could be a master or slave. It had Bluetooth low energy. It seemed to be a newer version of the more popular Bluetooth chips that are out there. However, I did make a note to myself after a number of hours. You'll see I made a note. This is an HM10 is what it's referenced as. You see mine's actually a knockoff. It's actually a BLE CC41A. So all the ACT commands are different. A lot of the specs are different. You'll see it's missing a button down here. You'll see it's actually missing a timer up here. So I spent tons and tons of time trying to get this one to work. Read a lot of forums about it. I could get it connected, but couldn't get any communication going between the Pi and the Arduino. A large reason for this, some people said, is because it is a knockoff, some of the firmware is wrong, and basically it renders the chip useless. So after spending a ton of time on this one, I jumped ship and went to the more popular HC05, and this one can be a master or a slave, but there's a lot more documentation on it. It is an older module, older protocols, but it does work and does work pretty well. So here is basically what the schematic looks like for what I've set up here. So what's happening is the Arduino is reading a temperature sensor. You can see this guy here. When it sends a signal to the Raspberry Pi over serial, it's going to flash this LED. When it receives a signal back or message back, it's going to flash this one. So what it's actually doing is sending through the temperature to the Raspberry Pi. The Raspberry Pi is then going to save it down to the disk on the Pi and send back a message saying that everything's good, I received your message. I created just a really basic protocol here using less than and greater than signs to kind of bookshelf in the degrees or the message that I want to send. On the Pi, a little bit of effort on this side, just figuring out how to get Bluetooth connected using RF comms and using Pi serial. The library itself is pretty straightforward. It's mostly just getting that connectivity. So basically what was happening is I could get it paired pretty easily, no issues there, but once it was paired, I couldn't get a connection, and the reason was because I needed to open up an RF comm to basically say that there's a reason why the Pi should be connected to the Bluetooth module. So once it's connected on RFCOM 0, we use a baud of 9600, and you'll see we're going to save the reading. We're going to add a date time to it. It's going to open up the file, save the date time down to it, and you'll see that there's a temperature here. So that's all coming from here. We have just an infinite loop, so while true, if there's something in the serial, read the character, then we have a whole bunch of protocol functions that just say, if it's the beginning or if it's the end or if it's not a character we want to recognize, blah, blah, blah. And then we get down to the point where we actually receive the numerical function, we convert it to a float, and then we write back saying, yep, I received your message, blink yourself 5 times to acknowledge that. So over here I hooked up just a button that allows me to interrupt. So if I don't want it to keep sending messages, I did learn that there's such things as timer and hardware interrupts on the Arduino, so this could be improved a bit, but we'll start this up. So if we run this module here, we'll see that it's waiting for data. And if I push this button, we should see the flashing coming through. So we saw 2 flashes. We see that it says we're saving the new reading down to the disk, and it's going to do this every 10 seconds. It's actually fairly reliable. I've had it running for days on end. Really quick and really cool. So if you've seen a lot of my forum postings, you've read about me saying that it'd be interesting to build a robot but offload the computational aspect of it. So this is a step in the right direction for me. Green flashing means the Arduino sending a message. Blue means that it's received a message from the Pi. So basically, if I can build a robot and offload the computational aspects of it to the Pi, I have full access to Python and machine learning algorithms and all those fun things. But I'm limited by bandwidth, latency, transmission speeds, things like that. So we can also see here, if I fire up this Python module right here, so we print off the header, so we print off the first 5, and we can see that I already have, over the past number of days, almost 30,000 entries saved to this disk. So it's just really cool. So we're set up basically a networked sensor. I can send the information over, read it, save it to a disk, and then I can do things with it. So I could do graphing functions, plotting functions, run algorithms against it, things like that. So anyway, check out the code, check out the diagrams. This took it way more time. I assume it's probably going to take more time than it's going to take me to build a robot, but learned a lot from it. Learned a lot about protocols, a lot about making sure you buy the right components, a lot about reading data sheets, instructions, app mode, and all that fun stuff. So anyway, check it out. It's really cool. Super happy once I saw the lights actually blink and some messages come through. So it felt like a good success.